Hello and welcome to another exam paper walkthrough. Today we're looking at the 2022 predicted papers from the Maths Planner or Maths Planner. Really great revision site. They've produced some excellent predicted papers over the course of this exam series, and this is theirs based on paper 1 and paper 2 being sat. They've condensed it down into topics and then created a really good question on each of these topics. Feel free to check them out. I'll put their website in the link, although their website is here, www.mathsplanner.com. Okay, let's make a start. Right, question 1. So we've got our expand and simplify. So for this, I'm going to expand the bracket first of all, and then I'm going to simplify. So if I expand that, I would get x squared minus 9x plus 4x, and then minus 36, and then I've still got to subtract 5 from that. So when I simplify that, I'm going to get x squared minus, I've missed my x off there, minus 5x minus 41. Okay, question 2, factorise fully. So I can take 16 as my number part out as a common factor, and they've both also got an x and a y in common, so I can take 16xy out as my common factor, and then I would need to times the first. I would need to times the common factor by x to get the first term, and then to get the second one I'd need to times by minus 2y. Okay, fully simplify, so everything's already factorised, so we can cancel down by common factors of that, leaving us just with 5x plus 1. And you can multiply that out, but I don't think there's any need to. Okay, question 2. James has two lengths of wire. One is 360 centimetres long, the other is 840 centimetres long. He wants to cut both lengths of wire into smaller pieces of equal length without having any wire left over. What is the greatest length of an individual length of wire that James can cut? So this is a fancy way of asking us for the lowest common multiple. No, it's not that. It's asking for us for the highest common factor, wrong way around. Asking us for the highest common factor of 360 and 840. So to do this, now that we're on the calculator stretch, I'll show you the quick version. Rather than break it down into its prime factors, I'm going to simplify the fraction. So let me get my calculator up. So I'm going to do 360 over 840, so that's going to give me 3/7. So my highest common factor is either going to be 3 times by 300. Sorry, I should have written that the other way around. So for your highest common factor, you're taking the numerator of one and multiplying it by the denominator of the other, and you can do it either way. They will both give you the same value. So times by 3, or 804 times by 7. Sorry. Or 840 times by 3. So both will give us the same value. And again, I'm still looking for the highest common multiple there, so I've messed up there again. I've got in my head it's sorted that I'm trying to find the highest common factor. Sorry, the highest common factor. So I'm trying to find the highest common factor, not the lowest common multiple. So that's where I've thrown myself off. So I'm trying to find the highest common factor of those two numbers. And the highest common factor is whatever we've simplified by. So 360 divided by 3 is going to give me a 120. So both of those are simplified by 120, meaning that the highest common factor is going to be 120. Centimeters. There we go. Okay. So question 3, simplify 4x squared y to the power 4. So we're looking at 4 to the power 4 is going to be 4 to the power 4. So 256. X squared to the power 4 is going to be x to the power 8, and then y to the power 4. Okay, write this number in standard form. So we want to place a decimal somewhere to make it a number between 1 and 10. So we're going to place it there. 0308 times by 10 to that, and then in effect I've moved the decimal point from there, so I've moved it 6 places. The second part, 2 stars are at a distance of approximately 1.5 times 10 to the 8 kilometers apart. Light travels at a speed of 3 times by 10 to the power 8 meters per second. So we've got a difference of units there. How many seconds does it take for the light from one star to reach the other star? Give your answer in standard form. Well, speed is going to be equal to distance divided by time. So in effect, I want to do 1.5 times 10 to the 8, but I need to times that by 1,000 to convert that into meters. And I want to divide that by 3 times by 10 to the 8. And I can type it into my calculator just like that. It probably won't give us a number in standard form, but that's okay. We can adjust it afterwards. So I've got my denominator in the wrong place, but that's okay. And I want that over 3 times 10 to the 8. So that's going to give me 500. So I then need to convert that into standard form. So that's going to be 5 times by 10 to the, and I've moved it 2 places. Question 5. Laura runs a small bakery in her town. Last year she sold 850 pastries in the month of December. This year she managed to sell 1,020 pastries in the same month. Calculate the percentage increase in the number of pastries sold. So I'm going to do this. I'm going to treat it as a percentage over 100 and then adjust it afterwards. So what I've got there is the new figure divided by the old figure times by 100, and I'm going to get 100 and something as my answer, and the something will be my percentage increase or percent. So 1020 divided by 850 times by 100 gives me 120%, which means that we've got a 20% increase. Right, question 6. The maths department at Queen Elizabeth School is investigating the amount of time students spent doing their homework each week. They surveyed a sample of Year 11 students and collected the following data: median, range, interquartile, upper, median. Okay, so we've not got the maximum value, but we can work that out from the range. On the grid, plot this information. So 1.5 is my minimum, so halfway between 1 and 2, I'm going to have a dash. The range is going to be 7.5, so that's going to take me up to 9. My interquartile range is 3. I'll come back to that one. So my median is 4.5. My upper quartile is 6. And my interquartile range is 3. So that means that my lower quartile would have to also be the interquartile range, which would be 3. Okay, so complete that into a box. So there we go. That's my box plot. The maths department also surveyed a sample of Year 10 students. Their data is represented in the following box plot. Compare the distribution. So this is Year 11 and this is Year 10. Okay, so my 2 statements are, one's going to be comparing the median. So the median, so Year 10 have a higher median. Higher median. And we can say that that means that they revise more on average. And then my second statement is going to be comparing the interquartile range. So we know that the interquartile range for this one was 3. So the interquartile range for this one, we've got 7 compared to what looks like 3.5. So we've got, that looks like 4.5 then. Sorry, 3.5. 1, 2, 3.5. Yeah, 3.5. So year 10 have a higher interquartile range. Which means that they are less consistent. Less consistent revision time. Okay, question 7. Complete the table of values. So I'm going to use the table function on my calculator. And I'm going to type the equation in for the first function of x. So alpha x squared plus alpha x minus 6. So I've got the function of x in. I haven't got a second one. I want my range to start at minus 3. And I want it to go up to 3. And I want to go in steps of 1. So there's my table of functions. So check the ones that we're known. So we're told when it's minus 1, it's minus 6. So I agree with that. And when it is 3, we've got the value of 6. So I know that I've done that right. So I'm looking at 0, minus 4, minus 6, minus 4, and 0. So we've also got that repeating pattern as well, which we would expect from a quadratic. So if we plot that then, so minus 3 and 0, minus 2 and minus 4, minus 1 and minus 6, and then 3 and 6. I then need to join these up with a smoother curve as I can. So I was trying to keep my wrist on the inside of a curve. It's not as easy to do on a laptop screen. So using a sharp pencil and a steady hand and keeping your wrist on the inside of the curve, you should get something roughly looking like that. Okay, so use your graph to estimate the coordinates of the turning point. So the coordinates of the turning point is this point here. So from my graph, I'm roughly going to estimate it as slap bang in between these two values. So that's going to be minus 0.5. And my turning point is looking like roughly minus 6.2. Okay, use your graph to estimate the solution of, and then we've got these two graphs compared. So I've already got the graph of y is equal to x squared plus x minus 6. So I need to add to it y is equal to x minus 3. So if I draw that graph, I've got gradient of 1 and an intercept on the y-axis of minus 3. So I can draw that straight away. Let me change my pen colour for this though. So minus 3 was my intercept, and then for every 1 on the graph, I go up 1. 1 across on the graph, 1 up. 1 across on the graph, 1 up. And then go in reverse, 1 back, 1 down. 1 back, 1 down. 1 back, 1 down. And then join them up if I'm using a ruler, we should find that this is a linear graph, a straight line. And then we just need to estimate their solution, so that point and that point. So we're looking at what looks like minus 1.7 and 1.7. So my estimates are x is equal to minus 1.7 or 1.7. Okay, compound shape is made from 3 congruent parallelograms. The area of the compound shape is 88.2. Calculate the value of h. Each parallelogram is going to be h high and 7 wide. So 3 parallelograms, which are both all of area 7h, has got to be equal to 88.2. So h is going to be equal to 88.2 divided by 3 times 7, so divided by 21. So back into 88.2 divided by 21 gives me the value of 4.2. So the height of each parallelogram is 4.2. Question 9. The diagram shows Pac-Man eating points, a very famous game of the 80s. The circumference of a single point is 8 pi, so each of these are 8 pi. The circumference of each point is 8 pi. The radius of a Pac-Man is 4 times the radius of a single point. Work out the area of a Pac-Man. So if I start by looking at the points to work out the radius of each point. So for each point, the circumference is pi d or 2 pi r. So let's say 2 pi r is equal to 8 pi. So r is going to be equal to 16 centimeters. No, it's not. It's going to be equal to 4. Think about the next point already. So we're then told that the radius of the larger Pac-Man is 4 times that. So the radius for the Pac-Man. So the radius is going to be equal to 4 times 4, which is going to be 16. So if we want to work out the area of the Pac-Man, well, the area of a sector is equal to the size of the angle divided by 360 times by pi r squared. So in this case, the angle is going to be 360 minus 73, divided by 360 times by pi times by 16 squared. So 360 minus 73 divided by 360, and I want to times that by pi times by 16 squared. So that's going to give me 9,184 divided by 45 pi. And as a decimal, that's going to be 641.164 ... So I've not rounded, and then to 3 significant figures, that's going to be 641. Okay, question 10. A local running club organises a 5k race. The organisers group the times taken of the runners in minutes as following. Write down the modal interval of scores. So the modal interval is whichever one has the most frequency. So in this case, that's going to be 30 is less than or equal to m, which is less than 35. Write down the class that contains the median. Well, the median position is going to, so I'm going to call that median position, is going to be equal to however many we've got. So we need to work out the total frequency. So that's going to be 15 plus 22 plus 35 plus 18 plus 10. That's looking like 100. So we need to add 1 to that and then divide by 2. So we're looking for that's 50.5. So we need to find the 50th and the 51st. So we then kind of keep a look at our cumulative frequency. So 15 plus 22 is going to be equal to 37, and then 37 plus 35 is going to be equal to 72. So our 50th and 51st both fall into that group, so the median, the class interval that contains the median will also be that group. Okay, part C, estimate the mean time. So the mean time, we need to take the midpoints of each values. So that's going to be 22.5, 27.5, 32.5, 37.5, and 42.5. And I need to multiply it by the frequency for each of those groups. So if I multiply those and add them up, that's going to give me 22.5 times by 15 plus 27.5 times by 22 plus 32.5 times by 35 plus 437.5 times by 18 plus 42.5 times by 10. So that adds up to 3,180. So to find the median, I'm going to have to do, to find the mean, I need to do 3,180 divided by 100, because that's the total frequency that we worked out here, or here. So divide that by 100 is going to be 31.8. Okay, question 11 then. Here are some cards. Here are some cards that Angie has face down on a table. She's going to pick two cards at random. Calculate the probability that the two cards Angie picks are prime numbers. So the prime numbers we've got are 2. 0 is not a prime number. 8, 3, 3, and 5. So we've got 4 prime numbers the first time we pick. So the probability of picking a prime number the first time is going to be 4 out of the 7 cards. And then the second time we've only got 3 now, assuming one was picked the first time, and we've only got 6 cards now. So if we cancel that fraction down before we multiply, so 2 and 3, 3 and 3. So all we're left with is 2 over 7. Okay. So for this question, we're trying to do a transformation. We're trying to do an enlargement. So enlarge triangle A by a scale factor of minus 0.5 with a centre of 5.5 and 6. So I'm going to start by marking on my centre. So 5.5 and 6 is going to be, I'm just checking I'm reading this right, is going to be that point there. Okay, so I'm going to do this a point at a time, and to be fair, actually, I'm only going to look at the movement of 1 point. So that currently is 2, 4, 6, 8 squares away from the, so I know it's not 8, it's 8 squares away from the point of enlargement. So if I times that by minus 5, I'd get minus 4. So it's going to be, so that point will go 4 on the other side. So 2, 4, so that point alone will go to there. And then if I think about, let's say this point here in comparison. So this point here is 2, 4, 6, 7 squares above and 1 square to the left. So it's going to go 3.5 below and half a square in. So that point there would move to there. And then if I do C in another colour as well, sorry, if I do the final point. So if I go this point, so 2, 4, 6 across, well, 6 to the left and 2 down becomes 3 to the right and 1 up, so that point's going to move to there. So then join them up. Obviously you'll do it with a ruler and a sharp pencil. So that's going to be my negative enlargement. Okay, question 13. So the area of the rectangle ABCD is 5x plus 11. Show that 2x squared plus 5x is equal to 3. Okay, so in effect, I'm going to multiply out this bracket, multiply out. So the area is going to be found by, actually, this is quite a nice one to do on the diagram. So treat it as a multiplication grid in a way. So 2x times by x, let's start here. 2 times by x would be 2x. 2 times by 4 would be 8. 2x times by x would be 2x squared. And then 2x times by 4 would be 8x. So those 4 things need to add together to make the area. So 2x squared, and then 2x plus 3 plus 8x would be 10x. Plus 8 is going to be equal to 5x plus 11. So I'm going to ignore the show that. Normally I would take everything over to the left hand side, so that would be 2x squared plus 5x minus 3 is equal to 0, but we were asked to show that 2x squared plus 5x, so add 3 to both sides, is equal to 3. So let me just redo my plus sign, it's gone a bit awry. Okay, hence or otherwise, find the possible values for x. So I'm gonna say that if I take everything over to the side, so 2x squared plus 5x minus 3 is equal to 0. So I'm going to try and factorise. If it doesn't work, then I've got the option of either using the formula or completing the square. So to make 2x squared, I can only have a 2x and an x. To make 3, I can only have 3 and a 1. Can I arrange them in a way? Both have got to be positive to make that. So that would be 6. That wouldn't work. 3. Sorry, 1 has got to be negative, 1 has got to be positive. So plus 3 there would give me 6, minus 1 would give me 5. So it does factorise. So based on it factorising, then I get 2 values for x. Either x is equal to minus 3, which we might not be allowed, or x is going to be equal to a half. So we're not asked to find the length at the moment, so I'm going to leave it as both of those answers. Work out the area of ABCD. So we were told that the area is 5x plus 11. So let's try first of all. If x is equal to minus 3, then the area becomes 5 times by minus 3 plus 11. Which would give us minus 5 times 3 is minus 15 plus 11, that would be minus 4, so that doesn't work. So arguably we can get rid of that value. I'm going to leave it in though. If I then look when x is equal to a half, I'm going to look at 5 times by a half plus 11. So that's going to be 5 over 2, which is 2.5. So plus 11, that's going to be 13.5 centimetres squared. Okay, question 14. Here are some graphs. So before we look at what we're matching to, so we've got a linear graph, so y equals mx plus c, with a positive c-intercept and positive gradient. We've got a reciprocal graph, so kind of a 1 over a function of x, or 1 over x. We've got a quadratic, positive quadratic. We've got a negative linear with a negative intercept, so a negative gradient and negative intercept. We've got a negative quadratic, and we've got a negative reciprocal. Okay, so match them up then. This is going to give us a negative intercept and this is going to be a linear. It's going to be a negative intercept and negative reciprocal, so that's going to be graph D. We've then got a reciprocal, the positive reciprocal, so that's going to be graph B. And then we've got a negative quadratic, so that is going to be graph E, so DBE. Okay, question 15. Prove algebraically that 0.2 reoccurring 7 reoccurring is equal to 0.4 reoccurring 7 reoccurring. So I'm going to do this separately, so I'm going to look at both numbers. So I'm going to say x is going to be equal to 0.27 reoccurring, 2 reoccurring, 7 reoccurring. So 100x, I'm times it by 100, so I have a repeating decimal pattern, so 27.27 reoccurring. Sorry, 2 reoccurring, 7 reoccurring. So 99x is going to be equal to 1 subtract the other, so that's just going to be 27. So x is going to be equal to 27 over 99. And then the second one, let's change colour just to make it a little bit clearer. So for the second one, I'm going to call y, that y, 0.4 reoccurring, 7 reoccurring. So 100y is going to be equal to 47.4 reoccurring, 7 reoccurring. So let's so 99y is going to be equal to 47, so y is going to be equal to 47 over 99. So x plus y is going to be equal to 27, we've got the same denominators, plus 47 over 99, which is going to be equal to 74 over 99, which is what we were asked to show. Okay, question 16. Write x squared plus 6x plus 7 in the form, so we're looking at completing the square, where a and b are integers. So I'm going to put the first two terms into a bracket, so that's going to be x plus 3, half the coefficient, x coefficient squared. That will give us x squared plus 6x plus 9, so I need to subtract 9 to get it the same as x squared plus 6x, and then I've still got a plus 7, which is the second part. So that's going to create x plus 3 all squared minus 2. So there we go. X plus 3 all squared minus 2. Okay, question 17. Write 7 over 2x plus 5 over x plus minus 2 as the single fraction in its simplest form. So I'm going to put it over the common denominator of 2x times by x minus 2. To do that, I need to times the first fraction by x minus 5. So that would give me 7 times x is 7x minus 14. And then if I times the second fraction by that, I need to times it by 2x, so that would be plus 10x. So we can simplify our x's, so we get 17x minus 14 all over, and I'm not going to expand that because that's not really simplifying it. So that's going to be my answer. Okay, here is a speed to time graph for a train. Work out an estimate for the distance of the train travelled in the first 40 seconds using 4 strips of equal width. So we want this entire area, and we're splitting it into 4 strips, so strips of 10 seconds. And what I'm going to do is I'm going to work out the area of each section. So I'll call them area 1, area 2, area 3, and area 4. I'm also going to write down these values. So that looks like 4. This is 10. This is 20. And then this is 36. So the area of shape 1 is going to be equal to a half of, it's a triangle, so a half of 4 times 10. Which is going to be a half of 14, so that's just going to be 7. No, it's not. It's going to be 4 times 10 is 40. Half of 40 is 20. The area of the second one is a trapezium, so it's going to be a half of 4 plus 10 times by 10. So that's going to be 5 times by 14, so that's going to be 70. The third area is going to be equal to, rather than write half of a half and then times by 10, I'm just going to write 5 lots of these two lengths added together, so that's going to be 10 plus 20. So half, so 5 times by 30 is going to be 150. And then the area of the fourth trapezium is going to be equal to, again, rather than write a half times 10, I'm just going to write 5. And then I've got 20 plus 36. So 5 times by 56, which is going to be 280. So my total area is going to be these 4 things added together. So I'm looking at 20 plus 70 plus 150 plus 280. So that's going to be 520 meters. Part B, is your answer to part A an underestimate or an overestimate? Well, what we've actually done is we've worked out the area of each of these shapes, and the actual area is actually slightly less than each of them because of the nature of the curve. So we've kind of got slightly less here, slightly less here, slightly less here, slightly less here. So we're looking at my estimate would be an overestimate. As all my areas are slightly larger than the curve, or the area of the curve, I should probably have written. Question 19. In a science experiment, Laura is combining 2 liquids A and B to create a new mixture. Liquid A has a density of 5 grams per centimetre cubed. Liquid B has a density of 10 grams per centimetre cubed. She combines the 2 liquids in such a way that the density of the mixture is 7 grams per centimetre cubed. Assuming the densities remain constant when the liquids are mixed, work out the ratio of the volume of liquid A to the volume of liquid B in the mixture. Okay, so I'm going to create a very basic table. So liquid A, liquid B, and then we've got the combined liquid C. So I'm going to look at density, mass, and volume. So the density of liquid A is 5, the liquid of density B is 10, and then the combined one is 7. So if we say that the volume of liquid A is X, the volume of liquid B is Y, then density is equal to mass divided by volume. So mass is going to be equal to density times by volume, so that would be 5x, and that would be 10y. This would be x plus y, because you need to add them up. This would be 5x plus 10y. So we know that density is mass divided by volume. So for liquid C, we've got that 5x plus 10y over x plus y has to be equal to 7. So if I cross multiply and then, so I'm going to remove that denominator by multiplying up there. So I know that 5x plus 10y is equal to 7x plus 7y. And then if I take all of my y off there, I'm going to take my y's to this side, my x's to this side. So that gives me 3y is going to be equal to 2x. So that means that as a ratio, I would need 3 lots of x to be equal to 2 lots of y. So that's my ratio. So volume A to volume B is going to be 3 to 2. Okay, question 20. Here are the first 5 terms of an arithmetic sequence. Prove algebraically that the difference between the square of any 2 terms in the sequence is always a multiple of 24. Okay, so I'm going to start by working out the nth term for this sequence. So the nth term is going to be equal to, we've got a constant difference of 6. So the nth term is going to be equal to 6n plus, what do I need to do to 6 to get to 7? I need to add on 1. So if I look at 2 terms then, so the first, I'm going to do it in reverse. So my 2 terms then are going to be, well, that in effect that would be my first term, and then my other term is going to be, my next term would have to be 6 bigger than that. So it would be 6n plus 7. So the difference between the square of any 2 terms, the difference between the square of any 2 terms of the sequence. Okay, so I'm going to say that the first term is going to be 6n plus 7, and then I'm going to subtract from that 6n plus 1, and I want them both squared. So if I square the first term, that would give me 36n squared minus plus twice the product, so 42, so 84n, plus 7 squared is 49, and from that I need to subtract 36n squared, twice the product, so that would be minus 12n, because I've got the negative here, and then minus 1. So that's going to give me, those would cancel, so I'm just going to, 42 minus 12 is going to be 72n, and then 49 minus 1 is going to be plus 48. And then that would factorise, so I can take out 24 as a common factor, and then that would be 3n plus 2. So 24 times by anything, since 24 is a factor, it must be a multiple of 24. So any result would be a multiple of 24, as 24 is a factor. Okay, question 21. So ABC and ADC are triangles. The area of ABC is 6.2 times 10 to the minus 3 meters squared. So we've actually got a difference of units here and here. Work out the length of DC. So if I call that X, we can start to plan. So we're given the area. Okay, so for this, right, so if I can work out I can use the advanced trig formula for area to work out this length here. So let's call that y for now. I can then use the cosine rule to work out this length here, which I'm going to call Z for now. And then if I've got that, I can work out that angle there using angles in a triangle, and I can use the sine rule to work out X. So that's going to be the strategy. Okay, so first thing I'm going to do is I'm going to manipulate this. So we've got it currently as meters squared, and I want it into centimeters squared. So if I do 6.2 times 10 to the minus 3, well, 1 meter squared is going to be equal to 100 times 100. So it's going to be 100 squared, so it's going to be 10,000. Okay, so centimeters squared. So I want to convert that. So I'm going to say that a half of 12 times by y times by sine of 110 is going to be equal to 6.2 times 10 to the minus 3 times by 10,000. Right, let's tidy that up a little bit. So that's going to be 6. So I'm just going to write it slightly differently. So I'm going to say that 6 sine 110 times by y is going to be equal to 6.3 times by 6.2 times 10 to the minus 3 times by 10,000 is going to be, let's type that in completely wrong, 6.2 so that's going to be 62. So y is going to be equal to 62 divided by 6 sine of 110. Right. So z, and that's going to obviously give me a decimal. I'm not going to work with that just yet though. So I want to say that z squared is going to be equal to y squared plus 12 squared minus 2 times y times 12 times sine of 110. So that will give me a value for z squared and a value for z. And then for my final part, I can say that DAC is going to be equal to 180 minus 115 minus 41. So that's going to be equal to 180 minus 115 minus 41. So that's going to be equal to 24. So x over sine of 24 is going to be equal to z over sine of 115. So x is going to be equal to z times by sine 24 divided by sine of 115. So let's start actually working out some of these values then. So first of all, 62 over 6 sine 110 is going to be equal to 10.9999965. So I'm not really going to use it, but I'll write it down. ... So that value squared plus 12 squared minus 2 times the answer that I just worked out times by 12 times by sine of 110 is going to be equal to 1 Let's just check I've typed that in right. I've poo. That should have been cos. I thought as I was writing it down I'd typed that in slightly wrong. So let's go back and do that again. So that's cos. So 62 over 6 sine 110 gives me that as my value. So that's squared plus 12 squared minus 2 times by the answer times by 12 times by cos of 110 gives me that as my value. So the square root of 355.1877, square root of that gives me 18.846 ... So my answer times by sine of 24 over the sine of 115. So that gives me I want to just double check that because I'm not happy with that. That seems 8.44 8.4579, so that would be, I want to just check that a little bit. Okay, so I'm going, I've just done some checking in the background. I'm happy with that, so I'm going to go 8.4 to 1 decimal place. So I've written that wrong, to 1 decimal place. So 8.5 centimeters. Okay, and that brings us to the end of the paper. Really nice paper. Good level of challenge on that. Really enjoyed that. Thank you very much for your time in watching the video. If you found that useful, do check out Maths Planner's other resources and papers. Really good site. Thank you very much for your time in listening. Best of luck with your exam on, what are we on? We're on Monday now, so on Wednesday. Final push now, final paper, all the best. Please feel free to contact me via the chat. I'm fairly quick on getting back to you with any questions or queries. Please remember to subscribe if you like.